All right, here's a video that goes over graphing radical functions, square root and cube root functions. Let's say we have this equation, f of x equals 2 times the square root x plus 3 minus 1. And we want to graph this equation. So let me just set up our little xy grid here. So x, y. Now for this one, you can think of this in terms of transformation. This is a square root function, and I'm just going to go through it with the transformations. I don't know that this is the easiest way, and let me go through an easier way in a minute. But the square root function goes through 0, 0, 1, 1, it goes through 4, 2, and it goes through 3, 9. And the transformations that have taken place are, it's been shifted to the left by 3. So 1, 2, 3. This point 1, 2, 3, this point 1, 2, 3. So that you end up with that function. Then after that, that 2 amplifies everything by a factor of 2. So now at this point, 0 times 2 is still 0, but 1 times 2 goes up to 2, and 2 times 2 goes up to 4. So now we have this function, and then finally the minus 1 brings all those points down 1. So now we have that point, and we have this point, and we have this point, and so now this goes through like that. Okay, let me clear off all of these things because the way I suggest you do it actually doesn't rely on transformations at all. The way I recommend you do this on the test is you make a table of x and y values. And we'll have to be a little strategic here in choosing x values that actually work for us. Let's start by choosing some number. Let's just pick 0. Now, usually 0 is a pretty good pick. Let's see what happens when we plug 0 into that equation. So that's going to give us, let me just give ourselves some more space here. That's going to give us 2, 0 plus 3 minus 1, which is 2. 0 plus 3 is 3, but here's the problem. We can't take the square root of 3 without getting a weird decimal. So that turned out to not have been a very good pick. So let's go back to the drawing board and strategically pick another value. What happens if instead of choosing 0, we picked 1? Let's plug 1 in here. And if we plug in 1, then we have 2 square root 1 plus 3, and then 1 plus 3 is 4, and square root of 4 is 2, and 2 times 2 is 4, 4 minus 1 is 3. So we have the point 1, comma 3. So let's delete all of that. And on our list we have 1, comma 3. Now let's see if we can think of another strategic value. All right, let's try negative 3. Now, negative 3 is a good choice because look what happens when I plug it in. Negative 3 plus 3 is 0. Square root of 0 is 0. 2 times 0 is 0. We get negative 3, negative 1. Okay, let's clean that up. Negative 3, negative 1. Now let's do another value. Let's try negative 2. So if we do 2, negative 2 plus 3, negative 2 plus 3 is 1. Square root of 1 is 1. 2 times 1 is 2. 2 minus 1 is 1. So we end up with the point 2, comma 1. We fed this equation, negative 2. We fed this equation a negative 2 and a positive 1 came out of it. Negative 2 was our input, positive 1 was our output. Okay, so now we can graph these points. And when we graph these, we end up with our equation. So we got 1, comma 3x is 1, y is 3. We have the point negative 3, 1, 2, 3, negative 1. And we have the point negative 2, positive 1. So we end up with this kind of curve. And we would have gotten the same way with our transformations. Now the next question it's going to ask you is about the domain and the range. So domain is how far to the left and how far to the right. So here, how far to the left, we are looking at that point. That's our furthest left. And to the right, well, is that the furthest right? It actually goes infinitely. So for the domain, we're going to write -3, comma, and this thing can keep on going as far as we want it to go, so we're going to do infinity. Now, -3 is actually on the graph, so we're going to use a square bracket including that. And for infinities, we always use a rounded bracket because you never get to infinity. Now, let's just check with our equation here. Here is our equation. Is there anything I can plug in there left of -3, smaller than -3? Could I plug in a -4? See what happens if I try plugging in a -4. -4 plus 3 is -1, and I can't take the square root of a negative, so -3 is the farthest left I can get. If I try going any further to the left, I'll get imaginaries. So that is our domain. Now for our range is the y values. How low can we go? How high can we go? So this is our lowest value, and our lowest value is going to be -1, and our highest value, even though this growth of this line slows, the further we go to the right, it will keep on going up. Slowly but surely, it will get to infinity. So the range is -1 to infinity. So that's our domain and our range. Okay, let's go and do that next one. The next one we have f of x is equal to the square root of -x minus 1 plus 2. So we're going to make our little x and y table here, and let's choose some values. Let's just try 0, just for fun, and see what happens. If we plug in 0, we get that. Now, what I suggest is when you do this on your paper, you really write out all these steps. Don't try to do all these steps in your head, because when you try to do a bunch of steps in your head, you're going to miss a negative, and it's just going to be a big mess for you. Square root of 1 is 1. 1 plus 2 is 3. So that gives us the point 0, 3. And that does actually work out. So that's good news. Okay, so we got 0, 3. Let's just keep on going. We'll try 1. So we got the square root of -1 minus 1. And see how I'm just doing one tiny little thing at a time? Right here, all I'm doing is simplifying that. The next thing all I'm doing is I'm simplifying this. -0, that's just 0. Square root of 0 is 0. 0 plus 2 is 2. And it's actually faster for you in the long run if you write out all of those steps. So that gives us the point 0, 2. Let's delete all of those. Actually, sorry, 1, 2. So we've got the point 1, 2. Let's keep on going. Let's try moving further to the right. Let's try 2. If we try 2, 2 minus 1. So just plugging in 2. And now we got the square root of -1. Square root of -1 is I, and that is something where we say, we can't graph that. That's an imaginary number, so that is not graphable. Okay, so 2, can't graph 2. And so this is question mark. Or you could say not in the domain. Use that word there. Okay, so if we try 3, we're kind of seeing the trend here. Let's just try 3 and see what happens. And you're already seeing what's happening here, right, guys? That's the square root of -2. That's another imaginary. So 3, ditto, also not on the domain. 4, 5, 6, as we go further and further to the right, we find things that are not in the domain. So 3, ditto, not in the domain. So if we move to the right, it's not working for us. Let's move to the left. 2 works, 1 works, 0 works. Let's try -1. And let's just see what happens when we plug in -1. -1 minus 1. That's going to be -2. -2 is 2. And we got the square root of 2 plus 2. So this is good, kind of. We know that it's in our domain, but it's going to be a value that's going to be hard to graph. I'm just going to plug this into a calculator, and we're going to get 3.414. Okay, so let's be a little bit more strategic and find something we can actually get the value of. Let's try, tell me if you see it. All right, do you see a value that's going to work? Let's try -3. If we try -3, then we're going to get -3 minus 1 is -4. -4 is +4. Square root of 4 is 2. 2 plus 2 is 4. So that gives us the point -3, 4. And let's go ahead and graph this. And when we graph it, what's that going to look like? We have the point 0, 3. X is 0, y is 3. We have the point 1, 2. X is 1, y is 2. We have the point 2, oh, just kidding. We can't do that. That's not in the domain. 3, same thing, not in domain. But we have -3, 4. So -1, -2, -3, 1, 2, 3, 4. And we have it coming like this. So if we further go further to the right, it's no man's land, but we can go as far left as we want. For example, if I pick something like -100 and plugged it in here, then that's going to be negative, but then the negative and the negative flip that back over to a positive. So we can do negatives. So for our domain, we're going to say -infinity all the way up until 1. If I try to do anything bigger than 1 and plug it into here, it's going to make some imaginaries. So our domain is -infinity to 1, and our range is going to be, this is our y value, remember, our range is going to be 2 all the way up to infinity. And that is a square bracket. I got to fix my brackets here. Square bracket. Because we can include 1. 1 does actually satisfy the equation. We got it here in our table. And we do have an actual 2 in our table. So because these are actually actual values it achieves, then I made that correction to give myself a square bracket. Infinities always get rounded brackets though. Okay, that is it for graphing.